My name is Nikita Bondartsev. I work in Telaka, and more specifically in a part of Telaka that is called Tendem. We're building a hybrid agent that combines the capabilities of AI and the human to deliver you the best results. Today I want to show you this GitHub repository, and more specifically an example of how to use our Tendem MCP in order to build your own agents that are capable of calling humans for help. I hope I will be able to make it clear to you that it's not that complicated. So let's first start with cloning the repository and making everything work on your local machine. So I copy the link, open the terminal, and clone the repo. Now let's look into this repo. Let's open the project, MCP demo. Good. By default, it opens the wrong folder, but what we're looking at is the examples OCR example, and here is a README. This README actually walks you through what needs to be done in order to set everything up, but let's first, let's not read it together, because I think that I can give you a shortcut. So let's start with creating the correct virtual environment for our Python script. So examples, OCR, and run UV sync. Previously it was pip, and it took quite a while to combine everything, but now it's much faster with UV. Thanks for that. Okay, so it's the correct virtual environment. Now we hopefully have everything we need. But actually not, because we also need to create the environmental file. So let's copy the example as it's suggested by the README, and let's also fill it in. So you need an OpenAI compatible endpoint with an LLM. I prepared some credentials here. They're of course just for demonstration, and the token is going to be expired or like revoked after this. You are free to choose your own. Basically, for the agent to work, it needs an LLM. And what is interesting is the Tendem API key. It's specific to Tendem. So let's go to the Tendem AI. After logging in and passing the onboarding, you will see such a page. We'll switch to the work with agents, agent builders, and generate the key. Let's copy this and set here. Okay, good. Now we have the environment set up. Now we can generate the examples. I will open a new terminal because it's going to automatically use the correct env. UV run make samples. It's going to create the local files. Let's explore them a bit. In the OCR example, there should be a file called document. Yep, here. Those examples are just the invoices. There is also the bad invoice. We hope that the agent is going to understand that it can parse this image and cannot parse this image and escalate it to human. After creating the environment and the samples, we can now see how the script actually works. I'm going to show you two flows. The first flow is the fully agentic one, where you use your own favorite framework, most likely LangChain, to enrich it with tools that are provided as a part of the LangChain Tendem package to delegate the decision whether to involve a human or not completely to the LLM that you use. And the other one is the OCR scripted. It's a second flow that is a little bit more concrete, more deterministic, where the decisions are controlled more by yourself, by coding, and the MCP is used as an API. So let's run the agentic flow first and see how it works. UV run OCR agentic. I've also set the max price. It's the price that we allow to send to the human. If the human wants more than this, the task is not going to be sent to human, not going to be approved. And let's also add this flag watch and make it verbose. Let's go. So you see it's launched. The logs show that there are 5 documents. Gradually, the model starts to read them. and for 2 images, the Tendem task is created. Don't worry, when the Tendem task is created, you're not built yet. There's also an approval step that you need to go through. Okay, so for now, let's stop it and try to look inside, what's happening inside. Let's go to the SRC, to the source code. The examples OCR, SRC, you can see the 3 folders. One of them is Agentic, the other is scripted, and the comma. I tried to separate intentionally those folders in order to show you how the whole flow looks like. So this is the Agentic flow. The idea is that you use tools that are created by myself in order to build your own agent. There is a function. It creates the client, okay, and launches the processing. Inside the processing, you have several tools that are given to your agent. So first tool is the report tool. It's a specific tool for the use case. In this situation, it's for the OCR use case. It basically takes the input from the LLM and stores it to the correct file, to the result. You can see that the report is, it contains the confidence that the model had while recognizing the characters, the nodes, the source, and also the fields that are to be extracted. Okay, let's go back. The other tools that are more interesting to me are the Tendem tools. You see there is a function that is called guarded Tendem tools that provides you with the list of tools from the package that are specific to working with Tendem. Let's look into Tendem tools, what there are. You will see somewhere here there are the definitions. The first tool is the tool called create human task. This just creates the task in Tendem. It's not yet built. This tool is not idempotent, so if you call it twice with the same input, it's going to produce a new task each time. It's intentional that it was separated to be quick without any waiting. Well, just a tiny bit of waiting for the API to respond, so it's synchronous. What it does, it sends the task and uploads the files. If you see the input schema, it's going to be quite understandable. So the request, a free-form request to Tendem, and the paths to files on the local machine. These files are going to be uploaded to Tendem servers for processing. And the human, when they go to start the task, is going to see these files as well. The next tool is called the check human task. It's already a waiting tool. So when we create a task, first the Tendem agent estimates what has to be done and estimates how much it's going to be cost. This tool starts the polling. After a Tendem task is created, internally on our side, a process is launched to understand what needs to be done better, because you could have sent, or your agent could have sent, a rather vague description, and Tendem wants to understand that the task that is going to be performed by an expensive human expert is going to be well formed, and you're actually going to get the thing that you want from us. That's why Tendem can ask clarifying questions, and definitely it needs to estimate the price of the task that you want us to do. So in order to understand what's happening, there is a check human task tool that is called by the agent, and it's waiting, internally polling our service, checking if there are any updates on the task. The updates may be of different types. The first type is the expected one, is that you are going to get a quote. Quote is basically the contract that we are going to hold to when performing the task, and the price that we want you to pay for this task being done. Another scenario maybe is that when the task is not clear for our agent, it's going to ask the customer or the agent that is using a question, a clarifying question. In this case, the agent is going to get a message in the chat, and this message needs to be answered for us to continue with quoting your request. This tool, check human task, runs till there are any update, either a message or a quote, and returns as a plain text what happened. So the message needs to be answered, and the quote needs to be approved or disapproved. The next tool is specifically reply to human task. So if there is a question in the chat, your agent, or you, if you use the API style, need to reply to this question. This is also purely text reply. It's going to be added to the chat with our agent. Our agent is going to understand what's done and re-estimate or provide a code. There may be some scenarios when reply to human task is not even called once. The final tool is wait for human result. After you get the code and after the code is approved, the human is going to perform the task. This process may take a while. So in order to not overload the agent with making it basically call the tool to check the status of the task itself, this wait for human result tool has something internally, this polling cycle internally, and goes to our servers from time to time to check if the results are there, and as soon as they are there, they are going to be returned as the output of this tool. Okay, so that's it for the tools that are given to the agent. Just to recap, the agent is going to have 5 tools. First one is specific for the use case. This is the report, how we make the report, store the results, and the 4 tools that are provided from the package to interact with the human. It's a quick and not idempotent tool to create the task, and then 3 idempotent tools with waiting. First, waits for any updates in the task. Second, replies to the task. Well, actually, it's also not idempotent, right? So if you call it more than once, it's going to also update the task twice, though there is some internal logic out there. And the last one is wait for human result, which actually waits till the result is there and spits out the result back to the customer or to the agent that is representing the customer. If we don't feel comfortable enough, and if you want a lower level API, well, the LangChain Tendem package also allows for that. These 4 tools that you just saw may be called programmatically. Basically, you can use our MCP as an API. This is what is covered in another folder that is called scripted. Here, there is another flow file. I intentionally tried to make the 2 flows similar to each other so that they could be replaced one by another. This scripted flow differs from the agentic one by a more deterministic approach. If in the agentic flow, the flow of actions was decided by your LLM, here it's more prescribed. So if you look here, you will see how the tools are called one after another from the Python code in a specific sequence. The extract function, which is a part of the scripted pipeline, tries to make the OCR automatically by using an LLM. It invokes the agent with some predefined prompt. This is something that we scripted beforehand. Parses the answer. The answer also contains the confidence, which is produced by the large language model that tried to recognize the characters. Let's go back to the main script. Here, if we're confident, which is controlled by environmental variables, then we go with this function, which basically writes the result. So this from model is going to conclude that the item is ready, and it can be used for, well, and it does contain the correct characters. If not, if we're not okay, then we can escalate to the human expert. This escalate function is going to talk to Tendem. So inside this function, you may see that first we try to understand if we already created the task. The previous scripted pipeline always relaunches the OCR. You can actually try to make sure that the OCR is not launched more than once, but if we're talking about an LLM, then maybe it's a price that we're willing to pay. We can retry. So here, however, we do not want to send the task to a human expert more than once, because remember, for each task that you approve, you are going to be billed from your API key. So that's why we construct a special identifier for the image, and there is a journal that stores the connection between the task ID on the Tendem service and the task that you want to do, the OCR task, I mean. So if you build your own pipeline, probably you may want to also implement such guard in order not to create the similar tasks. Okay, so first we do the prepare the task. Inside, most likely we're going to launch the create task function. So here, yeah, you see, client, create task. It does create the task the same way as the agent would have. Oh, it also separately calls the upload file, so it's even a lower level API that we're using here. Okay, after we create the task, when we also want to record that the task is created and launch all the pollings that we have. Inside this drive function, we are going to look at what's happening and deterministically try to process all the cases in order to cover everything and make sure that the task completes. This is intentional, that this scripted pipeline is more complicated. That's the whole point why we try to expose the abstract tools, the abstract 4 tools that you saw, and give the control over them to the agent so that you didn't have to write all this code yourself. So here you see the logic, if there is a code, if there is a result, if there are any questions from the Tendem, or if we are over budget. While we wait for the code to be created and to make sure that the human expert is going to connect, let's look at what is happening in the UI. So here you may see that a similar task formulation was generated. It was generated by the agent with a new image. At the moment, there is an estimation process happening. So Tendem, for each task, launched a special internal agent that estimates how much the work is going to be worth, what type of work it is. So we have different specializations of our experts, and the most suitable is going to be selected automatically for you. After this step is done, a quote is going to be returned, and your client application may decide if the quote that was produced is good enough. I mean, if it's expensive or not expensive. So decided to spare you some time and did not wait with you. So while you were away, the quote was created and it was estimated at $3 for the task. The cap is $5 as was set when we launched the script. So now we can see actually how the task looks like in the interface. Now, the last message from our agent was that it was uploaded, and the agent, the Tendem agent, reported that the activity was proposed with a human expert, and now actually the work of the human expert starts. We won't wait till it completes because it may be about an hour till we find the expert, and the expert is going to complete it. And there is also a QA procedure afterwards that you also won't see because it's internal to us. We want to make sure that we return you the task of a good quality. So it concludes the pipeline for now. When these tasks are going to be completed, the agent, your local agent, is going to see the results of the human expert and call this record tool that is specific for the use case to produce the actual output. The output is stored in this special file. You see that there are two items, two images that are not parsed. Actually, they are copies of the same image. They still don't have the extracted fields, but they are in processing. The rest are computed by the model itself. Okay, so let's come back to GitHub. To conclude what we covered today, we looked a bit at this repository, specifically at the example of how to build your own agentic pipeline involving a human. This example was about making an OCR pipeline with first your agent, an LLM, trying to do the OCR itself, and if it's not capable, then it called for the human expert. Oh, by the way, I wanted to show you how the image looks like. So this is the image that the LLM was not capable of handling. You see that it's quite blurry. As a human, you most likely will be able to recognize what's written here, but not every large language model is capable of this. Of course, there could have been done some pre-processing to make the image better, but if you don't want to spend a lot of time enhancing it, maybe outsourcing it to a human is a good idea. Or maybe when the quality is so important that you're willing to accept this a bit higher price for the high quality result that you get. Okay, coming back. So in this repo, there is this example. The example covers 2 flows. First flow is a fully agentic flow when all the decisions are made by your agent, and setting up such a pipeline is as simple as writing the prompt and connecting the tools that are exposed by the package. And a more complicated, yet maybe more deterministic flow, where you use the lower level APIs to connect a human to your pipeline, not necessarily agentic, because you actually can just write your Python code in order to just connect to our API through MCP and have a human expert inside your pipeline. That's it. Thanks for listening. If you have any questions, feel free to write issues in this GitHub or reach out. I will be happy to support you on this. Thanks for listening, and see you next time.